Missed production deadlines, simultaneous component stockouts, warehouses stacked with obsolete inventory, all while your frustrated customers wait on back orders. These are the symptoms of a manufacturing environment relying on retroactive reporting. This creates the reactive expediter, a professional trapped in a daily cycle of fighting fires after the system has already failed. A proactive planner operates differently. They engineer predictability and structural flow months before a single machine powers on. The difference lies in a strict dividing line. Production planning is strategic. It dictates what to produce, when to produce it, and how much is needed, operating over a rolling horizon of 3 to 18 months. Production scheduling is tactical. It governs the micro-execution on the shop floor today, dictating exactly which operator is assigned to which specific machine for a localized task. To navigate a production planner role, you need to understand both sides of this divide. We are going to build a first principles mental model of the entire production architecture. Master production planners architect cross-functional alignment, forcing the quantified trade-off decisions that protect a company's profit margin. The most common point of failure in fast-moving consumer goods is the presence of competing demand signals. The sales department pushes an aspirational forecast, while the supply chain plans against a conservative historical baseline. The organizational antidote to this misalignment is sales and operations planning, or S&OP. It forces the business to lock in a single consensus demand signal over a 12 to 18-month horizon. This S&OP flowchart begins with initial inputs, the sales forecast plotted against baseline capacity. These collide at the pre-S&OP phase. Planners force explicit trade-offs between service and costs. The cycle concludes with executive approval, resulting in a locked consensus plan for all departments. Consider an FMCG supplier like Fresh Foods Limited. Enforcing a strict S&OP cadence allows them to anticipate seasonal spikes, preventing promotional stockouts while reducing the financial burden of obsolete inventory. In an interview, when asked how you handle mismatched forecasts, explain that you use the S&OP consensus process to surface explicit capacity trade-offs before they manifest as shop floor crises. When departments operate from the same data, the factory moves from isolated silos to a synchronized operation where margins are defended by the plan itself. Once the macro-level S&OP horizon is set, the process pivots to the tactical reality of the shop floor. Amateurs fall into the trap of infinite capacity planning. They build optimistic schedules that ignore physical limitations, like machine downtime, maintenance, or labor availability. The professional standard is finite capacity scheduling. This method plots production strictly against actual mathematical constraints to prevent a cascade of systemic bottlenecks. This Gantt chart shows an infinite schedule crashing into physical reality. Overlapping tasks stack vertically, breaching the capacity line and triggering a bottleneck warning. Finite scheduling resolves this by staggering tasks, explicitly budgeting empty gaps for necessary setup and changeover times. If a textile mill switches a line from blue shirts to red shirts, failing to schedule time to change threads and clean machinery will destroy the entire shift's output. Use the term finite capacity scheduling to show your approach. Emphasize that deliberately avoiding 100% resource utilization creates the buffer necessary to prevent system-wide delays. A realistic schedule respects the laws of physics. Proactive bottleneck management is the true test of a tactical scheduler. Available capacity is useless if raw materials do not arrive on time. The planner syncs this pipeline using the company's ERP system and the bill of materials. Material planning is a constant exercise in finding exact equilibrium. You are balancing expensive inventory holding costs against the risk of a production stockout. We map this on a 2x2 matrix comparing volume against customization. Make to order minimizes holding costs, but extends lead times. Make to stock shortens lead times, but risks dead inventory. Just-in-time, flow, and batch models all map onto this framework based on specific supply chain requirements. High-volume automotive plants utilize flow and just-in-time to eliminate warehouse footprint. Custom furniture builders rely on make-to-order to maintain agility. Your material planning strategy must align directly with the product's predictability and life cycle. Inventory approaches require a conscious choice between holding costs and service risks. The planner selects the specific risk the business is best equipped to handle. The cardinal rule of continuous improvement is simple. A planner cannot optimize what they do not quantify. Overall Equipment Effectiveness, or OEE, provides the mathematical baseline for a manufacturing line's health. This is the OEE equation. Multiplying quality, performance, and availability determines the exact percentage of fully productive time. Pushing machine speed to its absolute limit often spikes the rejection rate. That drop in quality drags down the aggregate OEE score. A data-driven planner resolves this by adjusting the schedule to run the machine slower. Reducing the defect rate mathematically increases the net output of usable, sellable goods. Focus your answers on the gap between planned setup times and actual setup times, because that gap is where profit margins vanish. Continuous improvement requires a closed feedback loop. Yesterday's tactical execution errors on the shop floor must rewrite tomorrow's strategic S&OP assumptions. These built modules form a cohesive architecture for high-stakes decision-making. This layout summarizes our framework. Planning looks months out to align strategy, while scheduling executes the daily reality of the shop floor. Structurally, S&OP creates the consensus demand signal. Capacity scheduling must be finite. Inventory strategy must map to the business model, and OEE tracks the mathematical truth of execution. When asked how you handle a sudden, massive change in demand, avoid generic answers. Evaluate the disruption strictly against finite constraints and holding costs. Frame the exact trade-offs, like paying overtime versus delayed service, and present actionable scenarios to the executive team. When asked what makes a good production plan, be specific. A good plan is data-driven. It utilizes finite capacity with realistic changeover buffers and is fully integrated with the ERP system's material pipeline. Understand your identity in this process. You are a decision maker employed to surface trade-offs, not a reporter employed to file spreadsheets. The planner acts as the crucial cross-functional bridge, translating the commercial ambition of the sales team into the physical reality of the supply chain. Mastering this architecture allows a planner to safeguard the company's bottom line by translating commercial goals into precise physical execution.